G'day, have you ever looked up at the night sky? Of course you have. You see that big, beautiful, silvery orb hanging up there? That's our moon. It's been with us for a very, very long time. For as long as humans have walked the earth, the moon has been our constant companion. It pulls on our oceans, creating the tides. It lights up our nights, a beacon in the darkness. We've written poems about it, sung songs to it, and even dreamt of one day visiting it. It's a familiar sight, something we often take for granted, like the rising of the sun each morning. It just seems to be there, doing its thing. But what if I told you that this familiar face in the sky does much more than just look pretty? What if its presence is one of the main reasons life on Earth is even possible? It sounds like something out of a science fiction movie, doesn't it? A giant rock in space saving our planet. But stick with me, because the science behind this is truly mind-blowing. The moon is not just a passive observer in our cosmic neighborhood. It is an active participant in the story of our planet, a silent guardian that has shaped our world in ways we are only just beginning to fully understand. So, let's bring these ideas together. We have our Earth, spinning like a top. This spinning top is tilted over at an angle of 23.5 degrees. And as it spins, the axis itself slowly wobbles in a huge circle over 26,000 years. It seems like a lot of moving parts. A complex cosmic dance. And it is. But the crucial point is that this dance has been stable for a very, very long time. This stability has created the predictable seasons and long-term climate conditions that have allowed complex life like us to evolve and thrive on this planet. Now, imagine that spinning top without anything to keep it steady. In the vast emptiness of space, Earth isn't alone. It's constantly being nudged and pulled by the gravity of other celestial bodies. The Sun, of course, has a massive pull, but so do the other planets, especially the giants of our solar system, Jupiter and Saturn. Their immense gravitational fields reach across hundreds of millions of kilometers, constantly tugging on our world. Over the vast timescales of planetary history, these pulls could combine in chaotic ways, yanking on Earth's axis and threatening to throw our tilt into disarray. This is where the concept of chaos theory comes into play in planetary science. Without a strong stabilizing force, the gravitational pulls from the other planets could have sent Earth's tilt careening all over the place. Scientists have run simulations of what Earth would be like without its large moon. The results are frightening. The tilt could swing dramatically from as low as 0 degrees, meaning no seasons at all, to as high as 85 degrees, which would mean the planet is effectively spinning on its side. This is where our hero, the moon, steps in. The moon's own gravitational pull on Earth is much stronger than the pulls from those distant planets. Simply because it's so much closer to us, it acts like a massive stabilizer. Think of it like a tightrope walker using a long pole to keep their balance. The moon is Earth's balancing pole. To really understand how the moon applies this stabilizing force, we need to revisit an idea we touched on earlier. The Earth is not a perfect sphere. Because it's spinning, it bulges out around the middle. Think of it like spinning a ball of pizza dough. It naturally flattens and widens. This bulge might not seem like much on a planetary scale, but it's the handle that the moon's gravity grabs onto to keep us stable. The moon's gravity pulls on every part of the Earth, but it pulls more strongly on the parts that are closer to it. This difference in gravitational force is what creates the tides in our oceans. The moon's gravity tugs on this bulge, constantly trying to pull it into alignment with the moon's own orbital plane. However, the Earth is spinning. And just like a spinning gyroscope, when you apply a force to try and tilt it, it doesn't just fall over. Instead, it moves at a right angle to the force. Let's think of this as a cosmic tug of war. On one side, you have the Sun and the other planets, primarily Jupiter. Think of this as a team of rowdy players who are pulling on the rope at irregular intervals and in slightly different directions. On the other side of the rope is our champion, the moon. It's a single player, but it's standing right next to the line and has an incredibly strong and steady grip. The moon also applies a torque on the equatorial bulge, one that is much more powerful and consistent than the combined forces of the other planets. This lunar torque is the dominant force in the game. It doesn't stop the rope from moving, but it controls the movement completely. It forces the system into a fast, regular rhythm, our 26,000-year precession cycle, turning the chaotic tugs from the other team into a predictable, manageable wobble. Right then, we've explored the science of how the moon acts as our planet's cosmic anchor. But to truly grasp the importance of this, let's engage in a bit of a thought experiment. Let's imagine a world where the moon never formed, or one where it suddenly vanished from our sky. What would happen to our beautiful blue marble if it was suddenly set adrift, left to face the gravitational whims of the solar system on its own? The first and most dramatic change would be the loss of that stabilizing force. The cosmic balancing pole would be gone. Without the moon's dominant torque on our equatorial bulge, the much weaker but now unopposed torques from the sun and planets like Jupiter would take over. The slow, predictable 26,000-year precession cycle would disappear. In its place, a new, much slower and far more erratic wobble would begin. Scientists who have modeled this scenario have come up with some startling results. Earth's axial tilt, our magic number of 23.5 degrees, would no longer be stable. Over timescales of tens of thousands to millions of years, it would begin to swing wildly. The tilt could drop to near 0 degrees, meaning the planet would spin almost perfectly upright. Or it could lurch to extremes, perhaps as high as 85 degrees, which would mean Earth is effectively spinning on its side relative to its orbit. What would this climate chaos mean for life? To put it bluntly, it would be an extinction-level event on a recurring basis. Evolution, the slow and steady process that has crafted the incredible diversity of life on Earth, relies on a degree of environmental stability. If you radically change those conditions every few millennia, you don't give evolution a chance to keep up. Complex life forms like large plants and animals would be hit the hardest. Imagine you're a towering redwood tree, a species that has adapted to the cool, foggy coasts of California over millions of years. Suddenly, over the course of a few thousand years, your home becomes a sun-scorched desert or a frozen wasteland. Perhaps some life would survive. The most likely candidates would be simple, highly adaptable organisms, think bacteria, archaea, and perhaps some hardy fungi or algae. Life might persist deep underground or in the oceans, shielded from the worst of the surface extremes. But it would be a shadow of the vibrant biosphere we know today. The development of complex, multicellular life, let alone intelligent life, would be incredibly difficult, if not impossible. So, our journey through the science of planetary stability comes to a close. We began with a simple observation, looking up at that familiar silvery disk in our night sky. We have established that the moon is the primary reason our planet enjoys a stable axial tilt. This stability, in turn, is what gives us our predictable, reliable seasons. Think about agriculture, the bedrock of human civilization. Our ability to grow crops is entirely dependent on the predictable timing of the seasons. This reliability allows for planning, for surplus food production, and for the support of large, settled populations. Beyond the seasons, the moon's most visible effect is on the tides. This constant ebb and flow is a powerful force that shapes our coastlines. The most obvious example is the intertidal zone, that unique environment that exists between the high and low tide marks. These zones are teeming with life. Many of the world's most productive ecosystems, such as salt marshes and mangrove forests, depend on the daily flushing action of the tides. These ecosystems are vital nurseries for countless species of fish and crustaceans. The moon's influence goes beyond shaping the physical environment. It acts as a celestial clock that helps to synchronize the behavior of life itself. The most famous example is the mass spawning of corals on the Great Barrier Reef. Sea turtles often come ashore to lay their eggs during the high tides of a full or new moon, which allows them to nest higher up the beach, safe from the regular tides. On land, the effect is more subtle but just as real. The amount of moonlight can significantly affect the behavior of nocturnal animals, creating a shifting dynamic in the nightly contest between predator and prey. Even the predictable cycle of seasons, guaranteed by the moon's stabilization of our axis, shapes ecosystems on a grand scale. Think of the great wildebeest migration across the Serengeti, driven by the search for fresh grazing that follows the seasonal rains. This seasonal clockwork has driven the evolution of countless species. Deciduous trees drop their leaves in autumn to conserve water and energy through the winter, a strategy made possible by the certainty that spring will return. The moon's steadying presence has provided the long-term stability necessary for these intricate biological clocks to evolve in the first place. We've seen how this constant companion, so often taken for granted, is far more than just a pretty light or a regulator of tides. It is the silent guardian of our world, the unsung hero of Earth's story. Its presence is a profound stroke of cosmic good fortune, a key ingredient in the recipe that has allowed our planet to become a thriving, living world. The moon, through the simple, persistent power of its gravity, is our savior from this chaotic fate. By grabbing onto Earth's equatorial bulge, it applies a steadying torque, a gravitational handshake that has lasted for billions of years. Therefore, the next time you gaze up at the moon, whether it's a slender crescent or a brilliant full orb, take a moment to appreciate its true significance. You are not just looking at a barren rock. You are looking at the anchor that holds our world steady. You are looking at the architect of our seasons, the maestro of our tides, and the quiet protector that made our very existence possible. Our moon is not just a neighbor. It is an inseparable part of what makes Earth our home.